Hello everyone, I am Florian, welcome back to my channel. In this rapidly advancing technological era, amazing progress in the field of AI happens every day. Today's video will delve into 5 of the latest advancements in AI technology. VisRAG, farewell to document parsing. GraphRAG, a survey. RAGLAB, a modular and research-oriented unified framework for RAG. Rerankers, a lightweight Python library to unify ranking methods. Quantized Llama 3.2 models. Let's get right into it. First, let's talk about VisRAG. Conventional text-based retrieval augmented generation, RAG, methods rely on parsed text, which often leads to the loss of visual information in multimodal documents. In contrast, VisRAG uses a vision language model, VLM, to directly process document images, preserving both visual and textual information. In the retrieval phase of VisRAG, it employs a dual encoder architecture, mapping queries and document images into the same embedding space and calculating similarity through cosine similarity scores to find the most relevant pages. In the generation phase, VisRAG can apply page concatenation or weighted selection methods based on the capabilities of different models to provide answers with the highest confidence. VisRAG excels in handling complex files with charts and images, such as academic papers and contracts, but requires significant computational resources. This technology is well suited for data-intensive industries. This survey provides a systematic introduction to GraphRAG and its key components. While RAG improves on LLMs by retrieving relevant text, it still falls short in capturing deep relational knowledge, leading to incomplete answers. GraphRAG addresses this issue by leveraging the structural information inherent in graphs, enabling more precise and contextually aware responses. The workflow of GraphRAG is divided into 3 parts: graph-based indexing, G-indexing, graph-guided retrieval, G-retrieval, and graph-enhanced generation, G-generation. G-indexing constructs or selects a relevant graph database for efficient retrieval. G-retrieval retrieves the most pertinent graph elements based on the given query. And G-generation uses the retrieved graph information to generate precise responses. Two key issues have hindered the development of RAG. First, there's a growing lack of comprehensive and fair comparisons among novel RAG algorithms. Second, open-source tools like Llama Index and LangChain use high-level abstractions, resulting in reduced transparency and limiting the ability to develop new algorithms and evaluation metrics. RAGLab is a modular, research-oriented open-source library designed to close this gap. This figure is a comparison between RAGLab and some existing RAG frameworks. Although RAGLab currently has some limitations, like a limited number of algorithms and insufficient diversity in knowledge bases, it is poised for future enhancements to become a useful tool for researchers. We know that re-ranking is a crucial component in information retrieval and RAG, typically employed after the initial retrieval of candidate documents. The rerankers library is a lightweight Python tool that unifies various re-ranking methods. It offers a standardized interface for loading and using different re-ranking techniques, allowing users to switch between methods by changing just one line of Python code. Meta AI released its first lightweight quantized Llama models that are small and performant enough to run on many popular mobile devices. They primarily used 2 techniques for quantizing Llama 3.21b and 3b models: quantization-aware training with LoRa adapters, which prioritizes accuracy, and SpinQuant, a state-of-the-art post-training quantization method that prioritizes portability. Through these combined techniques, the quantized Llama models achieve a speed increase of 2 to 4 times, with a 56% reduction in size and a 41% decrease in memory requirements. That wraps up the content for today. If you found today's video interesting, please like, subscribe, and turn on the notification bell to receive updates on our latest videos. Thank you for watching, and we'll see you next time.